In this video, I'll talk about the oxidation numbers as well as some of the formal naming conventions for the coordination compounds. We're asked to give the oxidation numbers of the metals in these species, and the first one is Na2MoO4. So our two metals are sodium and molybdenum. Now sodium has a charge of 1 plus, so the oxidation number is just the same as the charge on the metal. So we can write it as +1. Now, that means necessarily that this ion, MoO4, written like this, would have to have a charge of 2 minus in order to balance out the two positive charges from the sodium. So how do we get to this 2 minus? Well, let's see what the oxygen gives us. Oxygen has a charge of -2, and there are 4 of the oxygens. So that gives a charge of -8 or 8 minus, you could say. So molybdenum must then have a charge of +6 or 6 plus to say 6 plus -8 would get us to this 2 minus charge. So I'll write that down here. We've got the oxidation number for molybdenum in this molecule is +6. Next example, K4FeCN6. This runs through kind of the same way, right? So potassium has a charge of +1. So that's the oxidation number for potassium. We also need to know the iron oxidation number because these are the two metals that we need to know about. Well, if this is 1, then we're going to have a charge of -4 on this ion. Let's write it correctly. We are going to need to have a charge of 4 minus, right? Because we had 4 of these positive potassium charges or charges coming from potassium. And so let's take a look at this. We know that the cyanide ion, Cn, has a charge of 1 minus or -1. We've got 6 of them, so multiplied by 6, and that gives us -6. So how can we get to the -4? Well, then iron must have a charge of +2. So I'll write that up here. Iron, the oxidation number of iron then is +2. Good, we've got the oxidation numbers for those. And what about this? Write the formulas for the following compounds. Pentacarbonyl iron. 0, that means that's the charge on iron in this one is 0. Now, this is one that does not have a cation or an anion because of the 0 charge on the iron. So this one kind of walks us right through this. Penta means 5. The carbonyl is the CO, molecule, if you will, carbon monoxide. And so we've got 5 of these carbon monoxides and an iron with 0 charge. It doesn't say anything about charges here, so we write the iron first in the formula, even though when we name it, we say the metals last. So we've got Fe, and then we have CO, and then we have 5 of them because of the penta. So that's the answer on that one. The next one, potassium tetracyanocuprate 2. All right, a few things here. We do have a cation here, so it's listed first, the potassium. So we know that we're going to have a potassium, K. What about this one? We've got 4. This tetra means 4, so 4 of these cyano, right? And then cuprate, so 4 times the cyano, that's Cn. And then the cuprate that's copper with a charge of 2. That's what the 2 means there. So what do we need to do to get these together, the copper and the cyano? Well, let's do this. Cu and then Cn, we know that there are going to be 4 of them, right? Now, copper has a charge of 2 plus, and cyano, it's actually a Cn minus. There's a charge on there. So we've got 4 of those. So that's a charge of -4. Let's change the color so you can see that. So that's a charge of -4. And we've got a copper, a charge of +2. So that's going to give a charge of 2 minus on this ion. Well, potassium, as we learned up here, potassium has a charge of +1. So what are we going to need to do to balance the two negative, the charge of -2? Well, we're going to need 2 of these potassiums. So in the end, we have K2 and the rest of this stuff. Cu, Cn4, and that is it. Absolutely, there's a lot to think about there. It's very helpful without a lot of practice. It's very helpful to have a table with all of the listings of the names on these. You know, what is cyano and carbonyl, for example. Now, I hope that was helpful as an introduction. If you did find that helpful, please consider liking it or